Hello again, and good afternoon. I hope everyone enjoyed the delicious lunch provided by the Courtyard Marriott. Before we get started with our next keynote speaker, I want to quickly take this moment to thank our media sponsors. Without these folks, a lot of the advertising and promotion for this event wouldn't be possible. So I want to take that time to thank the Allen Economic Development Center in the city of Allen, Texas, the folks over at BPI, or Business Process Incubator, and they have a great little table and demo station right outside in the hall. So if you have a minute, go ahead and check that out. CIO Review, modernanalyst.com, and Splash Media. So I appreciate all the work that they've helped us in getting this together and making this event possible. And before we all start falling asleep from that wonderful lunch, I'm proud to present our next speaker. He is the Chairman and Chief Executive Officer of the OMG, Executive Director of the Cloud Standards Customer Council, and the Executive Director, he doesn't have enough Executive Director titles, of the Industrial Internet Consortium, or IIC. He also serves on numerous industrial, technical, and academic conference program committees. Additionally, he speaks all over the world on issues relevant to standards, the adoption of new technology, and creating of successful companies. He is an active angel investor and was involved in the creation of both the Eclipse Foundation and Open Health Tools. It is my pleasure to welcome the best baritone speaker in the room to the stage, Dr. Richard Soley.
Baritone?
Baritone.
Baritone? Who said I'm a baritone? I can't believe you said that. Just for that, I'm going to speak below 2 octaves under C, middle C, for the rest of the presentation. No, I probably won't, because I'll be out of air within 2 seconds. I'm actually going to speak tomorrow about the Industrial Internet Consortium, so you don't have to worry about thinking about that for a bit. I'm going to mention some of it when I talk about standards at the end of this presentation. But I want to talk about a lot of the different things that are going on at OMG. Unfortunately, I'm probably not going to talk about the one thing that you want me to talk about, whatever that one thing is. As some of you know, certainly, there are about 100 standards efforts underway simultaneously at OMG and some other brands, as David was just mentioning. I'm going to try to give you an overview of how OMG thinks of ourselves today, and maybe a little bit different than what you expect. So how many of you are already familiar with the OMG? I don't even know why I'm asking, because there's lights aimed right in my face and I can't see a damn thing. Okay, yeah, okay. Yeah, okay, back to the baritone voice. That'll be more impressive. So a bunch of you, I did see some hands there, at least in the front row, and by the way, you really ought to go get some, sorry. We are still focused on one thing that is not what most standards organizations think about, and that is rapidly developing markets. The idea is not to create a standard and hope that people recognize that standard as something, important in the marketplace. The idea is to create a marketplace. That's why we, for example, require that there are implementations of standards before we adopt those standards, that we know who's going to be doing implementations of those standards, that we know what the IPR constraints on implementation of those standards. So really, we're somewhere on that tightrope between an ISO approach in which you don't standardize anything that's actually implemented because that's unfair to the other vendors. And at the other end, that wasn't a joke, I'm sorry, that's actually a rule. And at the other end, you just ignore standards organizations and just publish things and see what happens. We're somewhere in the middle. We bring together end users and vendors to determine requirements. We send those requirements out and we ask for companies to propose specifications. Then they can be end users, they can be vendors, they can be academic institutions, and all of those have participated in what we've done over the last 26 years. For those of you who don't know, I joined OMG as the technical director when it was brand new, was one of the founders in 1989. I think there are a few of you in the room that weren't born at that point. I was only 4 years old myself. I was precocious, yeah. So we're looking to create architectures that solve real problems. We're looking to solve problems in the real world. Whether those are in the military space, whether those are in civil government, whether those are corporate, it doesn't really matter. Solve real problems in the real world. And what you've heard all day yesterday and half the day today is about how implementations of those standards solve real problems in the real world. But it's communities that make that happen. And that's really what my staff does, is bring together communities figure out what those communities want to deliver, hand them an open, neutral, international process for achieving those results, and then carry out the process. Really, the first thing you buy is antitrust coverage, and that's really important if you're working with everybody in the industry to make sure you're working together, but working together under antitrust coverage. And we've now been sued a total of 0 times in 26 years, so there's something going on right. I think the most important thing about how we develop standards is that those specifications are freely available. You want an OMG standard? Most of you in the room actually aren't members. Just go to the OMG website, download it, print it out, make copies for your friends, give them away as Christmas presents. That's what I do. People don't really expect much in the way of a Christmas present from a Jew, so it's okay. Yeah, you can hand it out on a CD now. It used to be paper. We require, however, that implementations exist. So you can come to the OMG website and read about implementations of that standard. So it's not just on paper, not just on bits. It's actually something you can use, because otherwise, who cares? A standard that doesn't exist in the marketplace is not a standard. And we are a member-controlled, not-for-profit consortium. Yes, I've been working for a not-for-profit for 26 years. I'm not that bright. What can I tell you? Today, there are about 500 member companies that are participating on about 100 different standards efforts. I am not going to talk about all 100 standards efforts today. And I'm probably going to not choose the one that for example, there's been a lot of conversation this morning about the Unified Architecture Framework, which I think is so critically important that I'm not going to mention it after this. But there are a lot of standards that are very important, and you've heard about some of them today. I'm going to give you a little bit more detail about where those things are going. And then I'm going to talk about communities in general. So today, OMG works in 3 different areas. The area that we started in 1989, which is generally called middleware, we call it part of our horizontal or our platform infrastructure standards. In that space, we actually started with our first standard in 1990, a standard called the Common Object Request Broker Architecture, or CORBA. How many of you know what CORBA is? How many of you think CORBA is dead? Oh, I thought I had a sucker there. I'm sorry. Yes, I thought I had one. You're all carrying an implementation of CORBA in your pockets or in your purses. Hopefully it's turned to stun, as I just heard. I'm not sure exactly what that means, but I'm not sure I like it either. I usually say, even funnier, what I usually say is, don't forget to turn your cell phone to the loudest possible volume, because we all want to know when you get a call. The CORBA standard actually is still in use today. There are about between 5 and 6 billion implementations running, and yet people think it's gone. What I learned from that is that standards are most important when they disappear. Standards are most important when they give you that interoperability, portability, and reusability without anybody even thinking about it. That's a very powerful standard. Today, the CORBA standard is embedded in every Java virtual machine. It's what implements almost all of the middleware that's out there. And it's in every financial application, it's on every mobile phone, it's in every robot, it's all over the place. Its offspring, the data distribution service, powers most Internet of Things solutions, industrial Internet of Things solutions, but I'm going to talk more about Internet of Things tomorrow. The reason for that is quite simple. It's the only secure, transactional, interoperable, multi-language, multi-platform solution out there, which is kind of amazing. After 26 years, nobody's been reading things. Obviously, we're in the modeling space. Mid-90s, we decided to try and experiment. Any of you remember the mid-90s? Yeah. We decided, we were approached by a group of companies, actually more a group of individuals, especially Ivar Jakobsen, who said it's really time to get together to develop methodology, a standard methodology notation. Not a methodology, but a notation. So I remember quite well convincing our board of directors at the time that we could take our standardization process and apply it to something completely different than middleware. And that was the methodology notation. January of 1996 in San Jose, California, we had a meeting in a hotel like this. We had a room very much like this. We made sure to keep all the windows and doors open so the room would not explode with ego overpressure. You know the difference between terrorists and methodologists, right? You can reason with terrorists, exactly, yes, yeah. We usually say negotiate, but I'll go with reason, that's okay. And the result of that was the Unified Modeling Language, or UML. We were lucky enough that Rational Software, now part of IBM, decided to give us the UML logo and the name, which we applied to the new standard, which was very widely adopted, and I know quite a few of you are using it today in the best possible implementation, which is from, okay, I can't have to finish that sentence. They'll finish the sentence. I've got to be neutral. That's grown into a bunch of really important standards. So one that you heard a lot about today was the Meta Object Facility, or MOF. MOF is critically important, especially to those who know nothing about it. It's another of those examples where a standard is absolutely critically important when you don't even care that it's there. MOF is what connects all these different modeling languages that you're hearing about this week. SysML for large complex systems, UML for software, BPMN for business process models, UPDM for enterprise architecture. There has to be a way to connect them together. MOF is the way we do that. It's the way we specify modeling languages. It's the way that we get the same sorts of features like query, view, and transform out of those modeling languages. That's a very powerful thing. And MOF is, of course, itself a modeling language specified in MOF. Thank you. Yes, exactly. Right. If that hurts your brain, you'll get used to it. If it doesn't, ask the person next to you what the heck he meant. We also work in real-time and embedded systems. That turns out to be fairly important in a space where there are not a lot of standards, and we're doing our best to fix that. But in the late 90s, just after I became CEO, which proves to you that our board of directors is not that bright, that was supposed to be funny, we moved into vertical markets. I didn't appreciate those that didn't laugh the first time, by the way. We moved into 4 vertical markets: healthcare, finance, telecommunications, and manufacturing. And the idea was, if you address a smaller marketplace, but better defined with some specific standards that give you some real interoperability and portability in a well-defined marketplace, you can make a big difference. And actually, a little known secret, I proposed this to our previous CEO in 1996. He told me I was crazy. I started writing my resume, and fortunately, he got a job offer from one Eric Schmidt to go work for Novell. Maureen O'Gara, my favorite writer in Unigram X, wrote, "That's the first time I ever saw a rat swimming toward a sinking ship." And that's true, by the way. We moved into those 4 vertical markets. Today, OMG is in about 27 different vertical markets. Our newest is oil and gas, which is kind of interesting to some companies south of here. And if you're interested in any of those vertical markets, actually, you can go to the OMG website, drag down industries on the right. You can see the sorts of markets we're in. Today, there are 100 standards being managed through a group of about 35 or 40 different working groups. It's all available publicly for anyone to look at omg.org/schedule. For the Brits in the room, we have a version for you at omg.org/schedule. Usually only the British people get that joke, so thank you. We also have focused working groups, and I'm going to talk about these other communities as well. I want to get across to you the breadth of the standards efforts that are underway today. In the healthcare space, provider directories. In the financial services space, well, you've heard already today from a couple of great speakers about the financial industry, business ontology, FIBO. You may have heard about FIGI, the financial instrument global identifier. I can never remember what these damn things stand for. In telecommunications, the way that you manage telecoms devices today is a Corba interface defined at OMG. In the civil government space, in the military space, lots of things going on. Most importantly, we don't do it alone. If you try to do it alone, what you do is you end up with a bunch of stratified standards, a bunch of silos of standards, the same way that you get silos in your organization when the left hand isn't talking to the right hand. We have today liaisons with over 60 other organizations. They include a bunch of different ISO organizations. Anybody know what ISO stands for? ISO? International Organization for Standards. Or Organisation Internationale d'Entente. And in neither language is it ISO. They need to be fair, even in the name. So, whatever. I'm not making fun of ISO because they'll maybe be mad at me, and I don't like it when they're mad at me. We work with the International Telecommunications Union, with other organizations like ours. For example, the Organization for Advancement of Structured Information Standards, OASIS. I was able to remember what that stood for. The Open Group, Open Health Tools, open source organizations like Eclipse Foundation, We have a very strong working relationship within COSI. So for those of you who are using SysML, you may not realize that was co-developed by OMG and in COSI, which is the International Committee of Council and Standards Systems Engineers. That, yeah. A very strong relationship for 13 years with HL7, which stands for Health Level 7, I remembered that one, in which we take requirements from the HL7, we use that as part of our requirements process, and we develop standard models, standard services based on the HL7 Reference Information Model, or RIMD. Probably the single most important is ISO, with which we have a relationship called PAS provider. PAS stands for Publicly Available Specification. For those of you who have sat down and read the World Trade Organization rules, anybody? I was hoping somebody would put his or her hand up because he or she would be a liar. But it requires the use of ISO standards. So it's important to us that some of our standards become ISO standards. We actually did a deal with ISO and with the ITU, the International Telecommunications Union, more than 20 years ago, in which they would publish OMG standards as their own standards and sell for 320 Swiss francs what we give away for free, but whatever. That relationship was solidified and given an official name, PAS provider, and there are now dozens of PAS providers. So if there's a standard that you're thinking about using, standard like BPMN or SysML or UML or something, but you feel that you need an ISO standard for government reasons, for whatever reasons, come and talk to us because it may already be an ISO standard, and if not, it's something we can do. For example, we were approached about 2 years ago by the Japanese government, actually by a group of Japanese prefectural governments, what Americans would call states or Canadians would call provinces or Germans would call Länder. They wanted to use BPMN to specify the software that they wanted to buy, so they would know exactly what software they were getting when their RFPs that they send out to vendors. And they said, it's a great idea, but under our reading of the WTO rules, yes, they were liars, they felt that they needed to follow an ISO standard. So we actually inserted BPMN into the ISO PAS process, and it is now an ISO standard. I know you're all excited to hear that. Some of the 27 vertical application domains in which we work, just to show you that our graphical artist loves and is able to find really cool looking icons. Healthcare, finance, go hell with it, let me just move on. Some specific ones that I think are worth talking about. In the civil government space, we developed a standard with the support and heavy participation of NARA, the National Archives and Records Administration of the United States, for a standard way to manage records. I'll mention actually in more detail the NEAM development process that we've worked with the PMISE, the Information Sharing Environment of the Office of the Director of National Intelligence of the United States. The Office of the Director of National Intelligence has this office whose sole job it is to enable sharing of information among US intelligence agencies, defense and homeland security, tribal, state, and local governments as well. So for example, if you've seen See Something, Say Something, that's the program that they run. And also with mission partners. Took me a while to figure out what they meant by mission partners. It means intelligence agencies of countries that we like. With tremendous support from some states like Wisconsin and with the Department of Justice and the Department of Homeland Security, they developed something called the National Information Exchange Model, or NEAM. Anybody familiar with NEAM? We got a few, yes. So NEAM is slowly but surely taking over information sharing in the US federal government, the Canadian government, getting tremendous amount of interest in Australia, in Japan, and a few other countries as well. But they invented their own way of specifying information models, unfortunately. And in fact, there already is a way to specify information models. It's called UML. Which, by the way, Computer World insists on calling the universal markup language, so I've given up. It's the universal markup language. The UML, the NEAM UML profile was developed, I think it's now a year and a half old, but it's a way to specify these information exchange technologies using the UML. And I think there's a talk on that tomorrow. I saw that Corey Casanave is speaking tomorrow, and I assume that's what he's talking about. In the financial services space, you've already heard this morning a couple times about FIBO, the Finance Industry Business Ontology. This is something that's been a long time coming, but it's very important. We're developing it jointly with the Electronic Data Management Council, or EDM Council. Dennis Wisnowski just gave a great talk before lunch about this. It's a way to not replace all of the ways that information is shared in the financial space, but a way to translate between them. And this is a very general solution and a way that we think about standards at OMG. It solves what I call the N+1 problem. I was trained as an engineer, so I understand those of you who are engineers who look at the power sockets of the world and say, gee, 7 different power sockets, that's not a great idea. We could have one standard way to plug things into the wall. That would simplify things, and then every plug would fit into every outlet on every wall in the world. So that our smart engineer goes and creates yet another way to connect power systems to the power plugs to the wall. And the net result of that is not going from 7 to 1, but going from 7 to 8. And that's a reality of our world. And with modeling, we have a way to get past that. We have a way to abstract the different solutions that are out there and connect across them, that we can adapt between them. And I use this example because I travel the world all the time. In fact, I leave tomorrow and go straight to Russia. And not bad for a Jew, right? Yes, okay. In Latin. I don't know why I do those things. I carry with me, as many of you do, adapters that adapt between the power connector that God intended, the 2 flat blades. That's not funny. That's the Japanese standard, and therefore I'm sorry, yeah. Japan, Colombia, United States, Canada, I mean, who else matters? Let's be serious. To adapt between the 2 flat blades and whatever's on the wall. You know, there's the British one, and there's the Australian one, and then there's the 2 round pegs. By the way, the 2 round pegs that you find in Europe, there are 3 different diameters of those pegs. If you've ever tried to plug a German device into an Italian socket, you know exactly what I mean. So I carry adapters, but what's interesting about those adapters is something we should learn. What's interesting is those adapters cost me nothing. I can get it at a hardware store anywhere in the world for about $1. I can get it at an airport anywhere in the world for about $20. And a really good meal from Subway. No. My point is they adapt. I don't have to design that adapter. I don't have to build it. I don't have to maintain it. I just use it. And that's what modeling standards allow us to do. Not to replace everything that came before, but to connect them. A couple more things I can mention if they put the slides back up. Military and emergency management, there we go. Healthcare services, which I mentioned we do with HL7. The most important point is that last point on the bottom there, and that is what we're talking about is shared semantics, shared business processes, shared models. And to get to shared models, we need to have a shared way of modeling those systems. So some of the things that we're doing today, architecture-driven modernization, I don't know if you've been following that. It's what you call a too clever name. That would be ADM, which is, of course, MDA backwards. How do we take, it's not funny, it's just true. I hate the name, but it's okay. The important thing that they've done is how do we take knowledge from a piece of code written in some evil language like Java, COBOL, Fortran, C. By the way, they're not as evil as you think. My daughter is a theoretical quantum chemist, and I'll be happy to explain what that means to any of you as soon as I understand myself. What it really means, though, is she's a mathematician. She writes code in Fortran 77. And she sends me, she's 24 years old, she sends me snippets of code in Fortran 77, and she says, Dad, can you help me debug this? I know you know Fortran 77. And I say, yes, but in my defense, when I learned it, was 1977. That's what they still use. The architecture-driven modernization group started out from that direction of capturing the understanding, capturing the information from a piece of code so that you could then forward generate into a modern language, especially as modern languages change. What they're working on now, though, is automated source code metrics. That is, can we tell the quality of this code by looking at the code? So how many of you are using CMMI? Probably a lot of you. How many of you are tired of putting your hands in the air? Okay, there's 3 guys over there, yeah. The CMMI is a tremendously valuable tool for understanding the process used to develop software. but it doesn't tell you anything about the code itself. Right? You can actually have, thank you for saying right, yes, he's the only guy that agrees with me. But it doesn't tell you anything about the quality of the code. We have enough technology. You've heard about pattern matching all morning. We have enough technology to look at a piece of code and say, hey, you're not bounds checking on that array. There's a security hole here. So that's what we're talking about, is metrics on code itself. I'm going to be talking more about that in a minute. In our analysis and design group, that's the group that manages, for example, the UML standard itself, agent meta models, knowledge base access, standard updates to OCL and MOF and so forth. So that's a very busy group. It's been around for a long time. Our middleware and related services group, middleware and related services, MARS for short. I don't think it's that funny. We shouldn't let them name these groups, basically. The woman that came up with that name insists on sending out emails to the group that say, "Dear Mars participants and those caught in our orbit." I pointed out to her, by the way, that orbit is far outside of Earth's, but anyway. A unified embedded component model and updates to IDL. So I actually think of IDL as a sort of poor man's UML. It is a modeling language with only the ability to say something about parameters and interfaces. It is the modeling language that's used to describe essentially protocols for DDS or Corba. But there's still tremendous interest in that. There's all kinds of updates. We just published last year a Ruby on Rails mapping for IDL. I know you're all excited about that. Okay, none of you are. In our systems assurance group, operational and threat risk modeling, this is actually the other thing that Corey might talk about tomorrow. I hope he does. It turns out there are 54 different languages that we've been able to find for sharing threat models, threat and attack models, cyber threats. 54 different languages. Obviously, the thing to do is look at them all and come up with one replacement for all 54. See how many of you were listening. No, what we're doing, in fact, is a model of threats that can map to any of those 54 or any new ones that happen to get created. For example, the Department of Homeland Security's new taxi specification. And our business modeling and integration group is doing right now a UML profile for Archimate. I know that there are a lot of you in this room that are doing TOGAF, using TOGAF to specify your architecture frameworks, and I suspect many of you are using Archimate. It's important that we bring together these worlds of modeling, we bring together these worlds of enterprise architecture, and that's why we're doing a UML profile for Archimate. But more generally, 15 years ago, we realized that what OMG staff is good at is a little different. It's really about community management, bringing together people, individuals, organizations that want to resolve a problem between them, not necessarily standards, by the way, and want an open, neutral, international process to achieve that solution. In fact, the first of those organizations was the Service-Oriented Architecture Consortium, or SOA Consortium. Anybody remember the SOA Consortium? Yeah, some of you were probably members. Eventually, there were 1,000 member organizations of the SOA Consortium. We promised right at the beginning it would run for 3 years. At the end of 3 years, we shut it down and actually merged it into the BPM Consortium. But what we learned from that is that our expertise is really bringing together people, organizations, to solve problems. The SOA Consortium didn't do standards. What it did was it published white papers that helped organizations move to service-oriented architecture. Those white papers were written by other SOA Consortium members. Of the 1,000 members, roughly 980 of them were end users of that technology, right? And in fact, it wasn't just a technology issue, it was a leadership issue like most new technologies. We've now made that a core part of what we do. We have communities that are not necessarily focused on standards, but instead bring together people to solve problems in their worlds, and secondarily to tell us as OMG and other standards organizations, gee, this would have been easier if we had a standard in this area or that area. The 4 brands that we run today, obviously OMG itself, the Cloud Standards Customer Council, a name that I can only remember because I can read it off the monitor here. I just call it the Cloud Council, and it gets me in trouble every time, so don't tell anyone. Oh, they recorded that. The Consortium for IT Software Quality, which I was talking about a moment ago, and I'll give you some more detail on, and the Industrial Internet Consortium. How many of you heard of the Industrial Internet Consortium? Anybody? Okay, make sure you come tomorrow. I'm mostly talking about the IIC tomorrow. Let me start by talking about the Consortium for IT Software Quality. So I've mentioned the importance of CMMI as a way to specify, to measure the quality of the process used to develop software. The reality is, however, you can have a really good process that delivers crap consistently. And I can see from the number of you that are laughing, you've been there. You can also have a really crappy process that delivers quality consistently, right? We call that hero programming, right? That's when you've got a group of 100 and they can't do anything, and the hero comes riding in and solves the problem for everybody. Crappy process, great software. For those of you who haven't read Fred Brooks' The Mythical Man Month, I strongly recommend it. The Mythical Man Month is the original and still best exposition of the problem of adding more people to a project and therefore slowing it down. The specific project he was talking about at the time, I think it was like 1972 or 73 or so the book came out, was the IBM Future Systems project. It had 100 people on it and was falling behind, so they added, eventually there were almost 1,000 people on the project, which killed it completely. Because they ended up spending all of their time in meetings, basically. Nobody could agree what they were working on. Anyway, the Consortium for IT Software Quality, which is sponsored by Capgemini, Huawei, Cast Software, and Wipro, brings together hundreds of companies that want to do something about software quality by measuring the quality of the software itself, regardless of the process. Measuring process quality is still important, especially if you discover that you're turning out crap software. But it is not enough. You really have to measure the software itself, and that's what CISQ, or CISQ, that's what we're doing there. We have an executive forum that's led by OMG and by the Software Engineering Institute of Carnegie Mellon University. That's what that CMU-SEI thing stands for. And today there are more than 600 organizations, not all companies, government agencies, universities, and so forth, working together to figure out metrics for how to measure software quality in a consistent way and in an automatable way, right? A program that measures software quality in a consistent way. This is the structure, because everybody loves looking at structure diagrams. It was founded, I think it's about 4 years ago now, by Carnegie Mellon Software Engineering Institute and the Object Management Group. It brings together IT executives and technical experts these are some of the 600 companies. It's not all 600 companies. These were carefully designed to make sure I didn't mention any of your companies so that you would be angry. But I mean, the point here is they're not all hardware and software companies, right? They're companies like AXA, which by the way is an insurance company, and General Motors, which used to be an automobile company. Sorry, I'm in real trouble. I drive a Ford, I don't care. By the way, I drive a Mexican car, a Ford. It was made in Salinas, Mexico. My wife, however, drives an American car, a Toyota. Made in Kentucky, what are you laughing at? But you see systems integrators there from all over the world and so forth. This is just to give you a feel for the participants in the process. The most important standard, and the most important thing that this group did was insert into the OMG standards process a standard for what is now called automated function point counts. And the idea is, I can't tell you the quality of the software unless I have some consistent automated way of measuring the size of the software. The problem is, the metric that most people use that's automatable is lines of code. Having been a programmer once myself, I know how to make my code better. Lots more carriage returns. And I'm not the only one who figured that out. The non-automatable way is something called function point counts. And the great thing about function point counts is that if two people function point count the same piece of code, they'll always come up with two different answers. Worse, if one person counts it twice, he or she will get two different answers. Automated function point count, which is now an OMG standard, published about 1.5 years ago, is consistent, always the same, doesn't really matter what it counts. People ask me, well, what does it do? And the answer is a mix of what you might call function point counting, interface counting, and line counting, but it doesn't matter. What matters is it's the same every time, and it does give you a reasonable, so far anyway, of the studies we've done, it gives you a reasonable guess of how big the software is in terms of how much it costs to maintain it, how much it costs to replace it, and so forth. Then there's a bunch of metrics that are essentially the numerator of that, the defects per function point, or defects per size. And they relate to reliability, performance, efficiency, security, and maintainability, the most important of those being security. So the ones that CISQ started with, as you'll see in a moment, are all related to security. It is important, however, to work with existing standards in this space, such as ISO's 25000 and a bunch of other numbers I don't remember. The structure of ISO 25000 is, this is the terminology that's in ISO 25023. We name I should tell you, we name our standards with really weird names like Unified Modeling Language. And ISO has much better names, 25023, it's clear what that means. My wife always tells me I should have a blinking light that blinks, on my forehead that tells you when I'm being sarcastic, but then I pointed out it would always be on. Okay, not always. This terminology, actually everything I say is a lie. Okay, just checking. Software quality characteristics, sub-characteristics, software quality attributes, whatever you call that terminology, the important thing is you need to be able to measure those things, and they need to measure the things that you really care about. And the most important are security metrics. Some of you may have heard of the CWE, or Common Weaknesses Enumeration, developed by the US Department of Homeland Security and by MITRE Corporation, and led by this gentleman, Robert Martin. Thank goodness I can read. Bob's work for years has been collecting those descriptions of software that create security holes in software. Extremely powerful thing to do. And he's done it well enough that we can actually define patterns for what those bad software coding techniques look like, so that you can actually apply those metrics apply those patterns against real pieces of software and say, hey, you're not bounds checking. That's a security hole. This report that came out in, a couple of years ago, listed those common weaknesses, and the first 25 and most important, most common weaknesses in the common weaknesses enumeration are now automatable OMG standard defect metrics that came out of the Consortium for IT Software Quality. These are some examples: improper neutralization of input during web page generation. I'm not going to read this. Improper neutralization of special elements in SQL. That would be what's usually called SQL injection. These are two of the three most common errors that programmers make that create security holes in their software. The third being bounds checking, by the way. And those three are 3 of the 25. Those are the numbers of all 25 down at the bottom that are now available as OMG standards, and you can actually go out and buy software that will measure your software against those common weaknesses. One thing I need to warn you, however, there's a great article by 2 of the people that founded Coverity about 5 years ago in the Journal of the Association for Computing Machinery, JACM. They pointed out that every time they shipped a new version of their software quality code, all their customers' code got worse. Think about it, right? They're checking for more problems, so even without changing your code, it gets worse. So versioning turns out to be pretty important in that world. Where are we today? The quality characteristics metrics are, well, actually it says 1Q15. The first 25 common weaknesses are done, and the automated function point standard is done. There's future work going on with enhancement of the function point counting standard. There's a lot of interest, by the way, in technical debt. That is, what is the bad code that you put in your software that's something that's got to be corrected later, that's got to be maintained out of your code. And we are also looking at certification. So there's a lot of interest in certifying individuals for their ability to write good code or to measure code for the quality of that code. There's also a lot of interest in something we probably won't do anytime soon, which is certifying code to be defect-free. We're talking, by the way, to UL Underwriters Laboratories. They're interested in doing exactly that, so I think it will eventually happen. I got asked a couple of weeks ago at a security conference, when did I think that all the security problems on the internet would finally go away? And I said, when the insurance companies get involved. Actually, not a joke, I really believe that. So what can you do if you want to participate or you actually care about code quality? Obviously, you can join CISC. It costs the grand total of 0. But actually participating is worth doing if you care about particular weaknesses in code, you care about the quality of the code that you or your contractors turn out. You can contribute to the blog. There's quite a lot of interesting information there about code quality and measuring code quality. Attend the seminars that we run. They're mostly webinars, online webinars today, and so forth. We will be improving this community of about 650 member organizations today is constantly improving the quality metrics that we're developing and improving the existing quality metrics that are out there. Let me tell you about another of our communities that's completely different. The Cloud Council today is, I think it says 500 there, it does, but there are actually, I think, about 700 member companies today, about 1,000 individuals participating in this effort. And here what they're looking at is How do we share experiences moving to cloud computing? What did I learn negotiating with my cloud vendor that I could share with other companies that need to do the same thing? How do I move from a private cloud to a hybrid cloud to a public cloud? How do I migrate my data from my private data center to a public cloud in such a way that I still have security? And what are the steps to securing that? What are the pragmatic steps to moving to cloud computing? There's a steering committee composed of some major cloud end users, as you see, Boeing, Aetna, State Street Bank, Lockheed Martin, and so forth. They meet about once a month on the telephone. They meet quarterly, and it's sponsored by IBM, Software AG, and Dell. This organization has now been around for 3.5 years, and as it says, 500 plus members. Again, we can't put all the logos on the slide, but you see some of the deliverables that we have developed over the years, moving your social tactics and strategy in with your cloud strategy, analysis of public cloud service level agreements. So how do you negotiate a service level agreement with your cloud provider, migrating applications to cloud computing, and so forth. The organization's been around long enough that there are actually second versions of our service level agreement white paper and our security white paper. An interesting new one that's just in draft now, but available for review if you're interested, which is Cloud Architecture for Mobile Solutions, and Web Application Hosting Relation and Interoperability and Portability of Cloud Solutions. As you probably know, the cloud solutions from all of the major cloud vendors, Amazon, IBM, Salesforce, Google, and so forth, are not at all interoperable and portable. You can't take your implementation off of one and move it to another. This is not a standards organization, so all it does is publish white papers today. It also runs competitions for best implementation, and it has seminars and webinars and so forth. We just held a big seminar in Washington, D.C. back in March, and we have a webinar coming up next week. One of the outputs of this group is, gee, wouldn't it be nice if there were standards in some area, in some specific area, and they hand those requirements over to OMG and other standards organizations. But I want to talk about the most interesting one today, which is the community that we call the Industrial Internet Consortium. In the late 19th century, there was a huge change in the world, and that was the Industrial Revolution. The Industrial Revolution was about taking human brawn and moving it to machines. The net result of that was a huge leap in productivity and also an enormous loss of jobs. Although there was a net increase in jobs, huge net increase in jobs, part of which came from the increase in productivity and part of which came from the new kinds of jobs that existed, like maintaining those machines. Same thing happened at the end of the 20th century. End of the 20th century, we had the Internet revolution, which moved a lot of human connectivity to machine connectivity. Again, we had an enormous loss of jobs. A lot of those bricks and mortar stores, I don't know if you've been to in Barnes & Noble lately, but they're mostly full of toys. Because people, it turns out, buy their books sometimes from Barnes & Noble online, or they buy them from Amazon online, or other online bookstores. But new jobs were created. Anybody think of some of the new jobs that were created? I've put you all to sleep. Okay, I'll give you an example. There were not a whole lot of web administrators in 1990, or web designers. That's a fairly well-educated and fairly well-paid job as well. We think there's going to be a third wave. That third wave we think of as taking the internet technology and applying it to industrial systems. I'm going to give you some examples tomorrow in my talk about the Industrial Internet Consortium, which I hope will show you that that world, the industrial world, has been almost untouched by the internet. We've seen huge changes in the music world. We've seen huge changes in the delivery of products like especially books. We've seen huge changes in a few other markets, including the insurance market. But we have not seen changes in industrial systems, power generation, distribution, and transmission, medical device interoperability. I'll give you some examples towards the end here. That third wave is going to connect industry via the internet, by connecting the industrial systems with internet systems in a way that has not really happened yet. Today, if I'm a jet engine manufacturer like Pratt & Whitney or General Electric or CFM or AVIC or one of those, I sell that jet engine to a distributor. The distributor sells it to a wholesaler, sells it to an airline, puts it on their airplane. I can think of lots of examples where if I'm a manufacturer, I never hear from the product ever again. If it's a small device, if it's a rice cooker, I sell it to a distributor who sells it to a wholesaler, who sells it to a retailer, who sells it to another retailer, who sells it to the customer, and I never hear of it again. If I actually could keep in touch with that product, I'd know much more about how it's used, what the next product should look like, when it's going to fail, how I could make it more efficient, which I can't do today. Connecting that circle together from the manufacturer of devices to keeping track of how that device is used, either because I still own it and I'm leasing it to the end user, or simply because they did something more powerful than send me in the warranty card, and ain't nobody sends in the warranty card. Anybody ever sent in a warranty card? Ever? Even one? You. You're a strange man. How many of you have registered your products online? Wow. Did you actually think that was going to get you something other than an extended warranty? I'm just asking. Anyway. Gary will explain later. If I could keep in touch with that product, I could know when it's going to fail and make sure that a replacement shows up on your doorstep before it fails. I could make it more efficient. I actually think we're looking 20 to 40 years in the future at products that no longer fail, because I'm going to get delivered a replacement part on my doorstep, or even a replacement product on my doorstep. Think of the customer service that I get in that space, in that world. How much of the world is industrial and can be affected by this change in the way we apply internet technology? Well, this is an analysis by General Electric. About 4 years ago, the chief economist of General Electric, Marco Annunziata, wrote this report, and he analyzed the roughly at the time 70 trillion US dollar world market to see how much of that market could be affected. It was industrial, where there was no component of internet technology. And he came up with this number of 46%, which is a mere $32.3 trillion a year. If you could shift the quality of $32.3 trillion a year by 1%, that's, for those of you who are real slow at calculations, that's $323 billion a year. Not a bad market to go after. So there's tremendous interest right now in the industrial internet, and we've brought together players in that space in what we call the Industrial Internet Consortium, and this is its mission statement, which I'm very carefully not going to read to you except for the last 3 words, and that is transformational business outcomes. Don't care about the technology. Don't even care about the standards yet. What I care about is, how can I change those marketplaces that make up that 46-point-something% of the world economy and get a piece of that $323 billion for me? That, I have to look for transformational business outcomes. I'm going to give you an example later, don't worry, I promise. So last March 27th, 2014, 5 companies, AT&T, General Electric, IBM, Intel, and Cisco, came together to build a sandbox, to figure out what is it that we can do applying internet technology to industrial systems. We figured that by today, we're about 14 months later today, there'd be about 70 or 80 companies that would have joined us to try to explore that. I'm here to tell you this morning 176 companies are participating in this effort. We are not developing standards. What we are doing is building test beds, prototypes, demonstration projects. It's too early to develop standards. We don't know what standards we need. Build a test bed, figure out what needs to be done, and then we might give some input to standards organizations to develop standards. I'm going to tell you what some of those standards might look like. The membership is open to any public or private organization. We have government agencies, we have universities, and if you're interested in what's going on in the industrial Internet of Things, I'll be talking about that in much more detail tomorrow. I'm not going to read this slide at all. I'm just going to say, I get asked all the time, who's going to be the winner? What company is the leader in the industrial Internet? What company is going to control the ecosystem? And the answer is nobody. When what we're talking about is connecting across the value chain, the supply chain, the service chain, the whole point is connecting across corporate boundaries. So nobody's going to control that. So we need to bring them together to collaborate to figure out what it is that industrial Internet is going to look like so that we can build a marketplace. We're figuring out what those requirements are by bringing together players that want to apply internet technology to industrial systems. Sure, there's a marketplace in consumer systems as well, but that's not what we're focused on, because that ain't where the margins are. The margins are in manufacturing, they're in healthcare device integration, they're in jet engine performance metrics, they're in financial systems integration. I'll give you a couple of examples at the end. I've already mentioned this. So the question is, what standards will we need? As I said, we don't know yet. We're starting to discover that now as we go through the process of developing the test beds at the Industrial Internet Consortium. So there are too many standards. I mean, I'm sure you've all heard the joke. That's the best thing about standards. There are so many to choose from. We know we want standards, and when you ask people, That wasn't supposed to be funny, sorry, Pete. When you ask people what is holding you up from adopting internet technology and industrial systems, they always say security and standards. So we know we're going to need standards, but let's figure out what those standards are. Once we do understand what those standards are, yes, that last quote, that's the most important thing. Standards are the most important enabler for innovation in the world today. How many of you agree with me? How many of you don't agree? We're going to have a little pitched battle outside the door. Nobody had the guts to put his hand up. Okay. This is Beecham Research's review of where standards are needed in the industrial internet. No, it's not an eye chart, it's a stupid chart. Anybody here from Beecham? Oh, thank God. I briefed the guy that did this chart last week, and he agreed. It's a little bit complex. The point is, if you know you need standards all over the place, and by the way, even if you can't read it, most of the standards they call out are in vertical markets, like power generation. If you don't know what you need, go build it first and learn something, and that's what we're doing. But I can tell you where some of the opportunities are. One of them is in terminology. What does industrial internet mean? What does Internet of Things mean? It's a horrible term, Internet of Things. And by the way, there are lots of other phrases. There's cyber physical systems, there's the industrial Internet of Things, there's Cisco's favorite phrase, the Internet of Everything. There's a phrase that's been around for a very long time, machine to machine. Let's get some agreed terminology around those, but the only way that's going to happen is if we actually build some systems. Middleware. You look at all the standards, the new standards that exist in the machine-to-machine space, they're all just middleware standards. Sorry, moving bits and bytes from place to place is easy. Maybe it's not easy, but it's a solved problem. OMG's been doing it for 25 years. It's existed in the marketplace for 50 years. That's not the hard part. The hard part is how do we capture the semantics of jet engines so that I can build one predictive maintenance solution that works for CFM engines, General Electric engines, Pratt & Whitney engines, AVIC engines, Rolls-Royce engines, et cetera, et cetera, et cetera. How do I capture the semantics of healthcare devices so that I can integrate the different apparatus that are on your body when you're in the ICU, in an intensive care unit? How do I capture the semantics of power generation, distribution, and transmission so that I can integrate smart grids? Those are hard problems, and the only way we're going to solve that problem is with modeling. So you're in the right place, it turns out. Those models, that was supposed to be funny. Those models, what's that? Yeah, you are here, exactly. Yes, I should have a slide that says that you are here, but everybody knows they're here. Wherever you go, there you are. Those models have to be in vertical markets. That's how we're going to have impact on the world. We play at the bottom of the stack. So the data distribution service that I mentioned, this is the best way to integrate systems in the industrial internet. Is it the only way? I'm sorry to tell you no. There will still be AMQP, there's the new 1M2M protocol, there's MQTT, which is being pushed by IBM and Oasis, and there are scads of other middleware solutions. That's why we ended up with an enterprise service bus, right, to integrate the integration buses. It's the job of standards organizations to make sure that we bridge across them, but in fact, that's something we know how to do. In the middle of the stack, there's a bunch of things that you build on top of middleware that are critically important. Dependability assurance frameworks, that's a major part of what the systems assurance group at OMG does. Threat modeling that I've mentioned. Structured assurance cases, how do I know that what I've built actually works? It turns out in the industrial world, we actually care about a higher level of reliability than music players. If your music player stops, you might be pissed, but you'll just start it again. The brake lining factory that I worked in at General Motors 40 years ago, if it stopped, it lost $20,000 an hour, and that was 40 years ago. And this unified component model that I was just talking about for embedded systems is critically important as well. But what really interests me is the top of the stack. Models for healthcare, models for manufacturing, models for jet engine performance metrics, and so forth. We could put these in categories, but I'm not going to because it's boring. The horizontal platforms that matter are extraction and storage, big data. Know anybody that does big data? How about NoMagic Adaptive? Or is it Adaptive NoMagic? Or no Adaptive Magic? I've been working on that joke for 3 hours, by the way, so I appreciate the laugh. All I want to say is, you know, bully for them, but I lose a member. Anyway. Transport layer we've talked about, control layer, how do we pull these things together, especially when they have not been designed to work together. This is the ultimate system of system problem, and analytics layer. There are a lot of analytics solutions out there, and they are, in fact, free analytics solutions. Hadoop is the one everybody talks about. But Hadoop is aimed at the problem of integrating information from unstructured data. In the industrial world, almost all the data is structured. We know what's coming off the manufacturing tools. We know what's coming off the floor. We know what's coming out of the jet engine. We know what's coming off the healthcare devices, blood pressure, and so forth. So these are the areas in which OMG thinks we're going to be working. We are taking input from Industrial Internet Consortium. That input is already coming in from the first testbed that was announced. I'll be talking more about the Bosch Tech Mahindra testbed tomorrow. But even before it finishes phase one, the Bosch Tech Mahindra testbed is already throwing off requirements for device management models. How do we capture information about devices that are on a factory floor and their locations so that we know that the right tool is being used at the right time with the right part in the right inventory and used by someone who's trained to use it and so forth. This chart was done by the Chief Technology Officer of the Industrial Internet Consortium, Stephen Meller, a name that some of you might recognize, famous for the Schleyer-Meller methodology. All the different bits that need to be standardized eventually, and some of the names for those bits, for example, SCADA and so forth. But I think the most important is the one in the upper right-hand corner. How do we model these systems in such a way that those models outlive specific implementations? The only way to do that is by using modeling languages, and that's got to be a model-driven solution. But you're in the right place, as I said before. That's exactly what we're talking about here. Modeling is the core. Systems of systems are complex. We have ways to model systems of systems, SysML being the obvious solution. Nothing works better. We have languages that have been around for a long time. UML was first standardized in, anybody know? 1997. It's been around for a while. When was the first version of SysML? 2007, so you know, the systems world is a little slower. Sandy's gonna hit me. We've got languages even for specifying business modeling, for enterprise architecture. You hold the key to how to make those systems work. What does that future look like? I'll give you an example. For those of you who've never seen this, this is a high bypass jet engine like the jet engines that hung on the plane that brought you here. You probably, some of you may know that jet engines collect performance metrics in flight the entire time that they're in flight. And on a transatlantic flight, or a transcontinental flight in the United States, they might collect as much as a terabyte of data before they land. So clearly what happens is the jet pulls up to the gate, every airport has Wi-Fi, it uploads its data to the jet manufacturer, the manufacturer does benchmark real-time predictive metrics against benchmarks of that jet engine hanging on that kind of wing on that kind of plane. No, that's not what happens. What really happens is a maintenance guy, if the plane is on the ground long enough, plugs a USB cable into the jet. It's actually not even a USB, but don't worry about it. Downloads some data. At the end of his or her shift, if he's got time, he might look at the data and say, oh, that number don't look good, and send it off to the jet engine manufacturer, who maybe at the end of the month might run some predictive maintenance against it and say, gee, I think we better go find N5273 because it's about to fall out of the sky. Actually, jet engines are incredibly reliable, so it's unlikely to fall out of the sky, but if we knew more about how it was being used, we could make it more efficient. We could fix that bent blade on the third rotor of the inner core. Anybody know what this device is? What's that? Yeah, it's an oxygen sensor, O2 sensor. It's got fancier names too. Somebody over there knows the fancy name, I don't know. See, he knows the fancy name, I'm not gonna say it. It's an O2 sensor. Tells you how much oxygen is in your blood. It turns out if you have lower than a certain amount of oxygen in your blood for more than 4 minutes, you no longer have to worry about anything ever again. It also turns out that we all have different thicknesses of skin, and we all have even different thicknesses of arteries. What will really make you unhappy is about 20% of the readings off this device are wrong. What's really bad about that is nurses know that. So if they get an alarm in an intensive care unit, an ICU, where they've got 50 patients, and they only get one alarm from your room, well, we'll wait for a second alarm. Not funny, actually, true. That's a problem. What really makes me angry about that world is we know that if your oxygen is falling and your respiration is falling at the same time, it's time to get a crash cart into your room. So obviously all you got to do is integrate the respiration sensor and the O2 sensor. Guess what? There is no single vendor that makes both. There is no oxygen sensor and respiration sensor that run even on the same bus, on the same protocol. And integrating them is hard. There's a lab that Partners Healthcare in the Boston area has been trying to do this for 4 years. They've actually done it technically, but now they need to get approvals. They need to get companies to ship it, et cetera, et cetera, et cetera. In the meantime, people die. We can actually solve some of these problems with industrial internet solutions. Here's my personal favorite because I like money, unlike you. Why do I run a not-for-profit? I forgot again. If you could track every trade in the world from every trading floor and every trading and every exchange in the world simultaneously, you could actually look at that and say, gee, this looks like a trading situation that we've seen before. Say, I don't know, some interesting times might be November of 1929 or September of 2008 or October of 1987. Hopefully some of you remember at least one of those. And say, this is something where we can provide some visualization to decision makers and stop trading temporarily, or actually at least notice that something's going on. I think that's already happening. That's what high-frequency traders do. There's a pattern here. Take information from sensors, potentially planet-wide, do real-time predictive analytics on that information, and then deliver the results either directly to actuators around the world or deliver visualization to decision makers. Every single level of that needs to be modeled. Every single level of that is going to need standards, and that's what we're doing. Those standards are going to look like these standards. SOML, SysML, BPMN, UML, UPDM, ABC, DEF, GHI, JKL. Hell with the names. It's about modeling systems and making sure those systems work. I'll just leave you with these final thoughts because I'm sure I'm over time because Ray's making eyes at me and they're not googly eyes. OMG is now 26 years. We've developed our standards process in the first year. We've run it 1,000 times in 26 years. It takes an average of 17.5 months. At least 3 times today I've heard, well, standards take time. They don't take that much time. I think it was Dennis Wisnowski. Dennis, are you there? 17.5 months average over the last 1,000 standards processes we've run. Vertical market focus is very important, but really what we do is bring together communities. I hope you'll think about joining those communities. I apologize for this photograph. It was taken 75 pounds ago, but my doctor's happy. Thank you very much. Do I have any time for questions, Ray? David? Yes. Is there a question, or you want to hold it for my talk on industrial internet tomorrow, which will be much more exciting, I promise, but I'll have fewer jokes. No questions? Was that a white flag over there? That's just rubbing his forehead. Okay, I'll stop making fun of you. Thank you very much. Thanks, David. Sweating.
We're going to have some more sessions on the 2 tracks opening up just shortly out in the hall, so make sure to check those out and check out our event sponsors out there. And we will meet back here at 3:25 for John Zachman's presentation on enterprise architecture. Thank you very much.